Hey, Cassandra, who all is here right now? Let's see if Mubot's awake. If you're in the chat, feel free to say hi. There we go. Chat's looking good. If you have questions, let me know. Get everything adjusted here on the screen. Looking good. Oh, it looks like that. Elizabeth, great to see you here. Who's got questions? If you're wondering about Stat 201, BAS returning. Kaya, good to see you here. Awesome. Patsy, great to see you here. I got the coffee. Got to make sure I don't spill it. Got a full cup of coffee. If you have questions, let me know. Which chapters are we working on? Which assignments are we working on? Drop the questions. Shira, good to see you here. Awesome stuff. If you have questions, just drop them in the chat. There we go, right here. Well, I like this one. It's nice to like a little relaxing music right here. Coffee in the vet mug. Of course, Kaya, you got it. Veterinary medicine, because people are gross. Can we over quiz 2 on Pearson? Of course. I need to put it on live chat. I was wondering if you go over the stem and leaf on the chapter 2 homework. About to work on the quiz. You got it. Let's see. Which quiz question are you wondering about here right there? Let me know. We'll do the stem and leaf on the chapter 2 homework. And then tell me which question you're wondering about. So always like start off, especially for quiz questions, be like the question that says this, like Center for Education, different things like that. Or the stem and leaf one on the homework. Homeworks have less questions. So the more detail you can give on the question, the better I can find it. The quizzes go in different orders. Oh, so for the quizzes, they'll be in different orders. So every time you take the quiz, you get different questions. So especially for the quizzes, I won't be able to know which question it is unless you say like the Center for Education question, the football question, enough information. So basically, like for any quiz, Center for Education, you bet. We'll do that one here next. I'm working on the visualization too. I want to make sure I'm doing it right. What do you mean by a short write-up? Basically like explaining it, explain the numbers, give the numbers context. So if you're talking about a box plot, or not a box plot, you're talking about a bar chart, you'll mention like the percentages or the counts. If you're talking about a pie chart, percentages or counts. If you're talking about a histogram, you'll talk about the mean or the median, depending on the shape, or the IQR and stuff like that. Let me know if you have questions. We could go back, Kaya, and talk about that, but let me know. Let's start out chapter. Here we go. Let me put a note here, and then we'll do Center for Education next. 330, chapter, or Stat 201, chapter 2, homework, or homework 2, chapter 2, homework, problem 1. Okay, let's check this out right here with some stem and leaves. Let's do it. Okay, so here is a stem and leaf. Now, the first thing we should look at in a stem and leaf is the what for the stem and leaf. Whenever we get a stem and leaf, we should probably look at the this. Like, write this down, be like, okay, if I ever get a stem and leaf, I should first look at the what of it. What do you think we should always look at when we get a stem and leaf? You get a stem and leaf, you should probably understand the context of it and what the numbers mean. I should look at the what for it immediately. I should look at the what for it. I should look at the what of it. If I get a stem and leaf, I'm going to look at the what of it. Take a look there for a hint. Get a stem and leaf and look at its this. Who knows, for 50 points in the chat. Anytime you have a stem and leaf, we should always look at... The number line is good right there, Kai. Good answer right there. The key. So the key is going to tell us information about how it should be read right here. So 7-3 represents 73. So this number line right here is just a number line. Those are not observations. There are a total of, I can count the seasons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There were 14 seasons of Mark McGwire right here. He got 2 home runs in a season, 22, 27, 31. Each of these is an observation inside of the 30s because the leading number is kind of the starting of the observation, where 7-3 represents 73, 6-7 which would represent 67. This one is not a number or not an observation. It's just a bin for anything that would have been in the teens or 10 through 19. There were no seasons where he got 10 through 19 home runs. Now, when we talk about the idea of unimodal, bimodal, or uniform, usually people get stuck on this uniform idea. So unimodal, and feel free to answer all of the questions, unimodal means one mode. Bimodal means 2 modes. And uniform means one form. Always break down the words into their components like uniform, unimodal, bimodal. And remember that uniform means like one flat form. So this definitely looks more unimodal right here. It looks more unimodal. And now we have right here, which way is it skewed? Now this is where usually the errors occur on this one. This is where the bigger errors occur. What is our saying? You should memorize the saying, see if you have it down. What is our saying for right to the high? What to the what? Oh, we already got a bunch of Monster Man pictures here. It's opening up all my Word documents from yesterday. What does it say? What is our saying? We already got a bunch of pictures of our Monster Man. There's a Monster Man. So what does the saying go? Right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low, whatever way the tail goes. So let's take our distribution and let's draw it. Now there's a common error on this one because when you draw your Monster Man right here, he's a little weird looking Monster Man. Hard to find his tail a little bit. Maybe I'll even get it wrong today. We'll find out. It's more of an outlier right here. He's got a long nose right there. But you might say this is left skew. You say, Brian, this is left skew. We take a picture of a picture now. It's not going to be left skew, though, because here's the issue people run into. A lot of people will say that this is left skew, but remember, right to the high. It's not left skew because a lot of people do this right here. If you do this, your number line is reverse. So numbers don't usually go from 7 to 0. They usually go from 0 to 7. So you have to actually flip it and see that it is actually a little bit right skew. The number line is properly oriented right now. And we can also see that the number line here in the original image, yeah, I think we do some visualization number 2, Alexa, definitely. Looking at tons of Monster Mans everywhere on my screen. All the Monster Mans. So his tail goes a little bit to the high side. So it should be a little bit right skew. Because remember, it's right to the high, a little bit to the high side. Am I right? Woo! Got a little bit scared there. Little tiny bit of right skew. Little Monster Man tail. That's more of an outlier down here. The center of the distribution is probably in the 30s or 40s, maybe upper 30s. That's where the peak modal area is. So the center is probably around here, the peak modal area. I think we'll do that coming up here next. Or we have a chapter, or someone asked about the Center for Education. So we're gonna do Center for Education question. Then we'll talk over some visualization too. There we go, right there. And then the number of home runs goes from what to what. So we need to find what two values right here. This is basically asking, if we're doing the range, I need to find what value here and what value here. What would be, it goes from, now you might tell me the values, but I need to be able to read this and find for the range the this value and the this value. So if we're talking about the range, you would say, well, it goes from a this like conceptual value to a this conceptual value. Is the best way? I think so, Kaya. And we won't ask complex IQR questions on the test. So just know the IQR is the range of the middle 50% and the min to the max. Kaya, great answers right here. Keep them coming. So the minimum value is 2 because that's 0, 2 if you decode it. And then the maximum value is 73. So that's a range of 71 if you mathematically find it. I agree with Patsy right there. 0, 2. Patsy, that is correct. I wonder if it would have accepted 0, 2. I would hope it would. So that's kind of an unusual feature, right? Like 2 home runs is pretty bad. Like I feel like I could get 2 home runs. I can't. But that is, now yours might or might not have an unusual feature. I think sometimes they change this question. It is kind of unusual that he got 2 home runs. Look, I might get this wrong. We got it. It's kind of unusual. Is it really unusual? If you feel like this question, it's a little bit unusual because it's kind of close to the center. I think what makes it unusual is that there's a what in the data right here. Yours might have been not unusual. I think sometimes they change this up. Now, why is this probably an outlier? Because there's a what in the data right here. 3-letter word, fall into the what. So mine might be more of a unusual feature because this might be more of an outlier because of the what right here. The gap. So there's a gap in the data. Hey, Matthew, good to see you here. Oh, Matthew, thank you so much. 100 points random Matthew showing up. We throw out some crazy points all the time. Matthew, thank you for showing up and saying hi. If you ever, I think because you took the class, so if you just wonder anything, let me know. Let's head back here to the main screen Center for Education time. Let's do this. So great work right there on that question. Good practice understanding the way distributions are drawn right there. And I love when former students come by. Matthew, thank you so much. Like, my outlier was 73 rather than, oh, your outlier, It can be different outliers, different unusual features in the data. And let's go here, Stat 201, Chapter 2 quiz. Center for Education. You're welcome, Cassandra. Ask another question if you got it. We've only got Visualization 2 after this. So the next thing after this is Visualization 2. I need a coming up next. I've actually wanted to make that for a while, like on TV shows where it shows you like coming up next. Oh, that's awesome. Helping out friends, that's worth points right there. Thank you for helping out your friends. Yeah, keep helping out, keep asking questions, keep working together. It's so much easier when you have a friend who's taken the course and you can just say to them, how do you do this? What does this mean? I try to offer as much help as I can, but shout outs to all those friends helping friends right there, helping them learn, because there's a lot of things to learn. And literally I'm meeting with someone later today who's going to help me make a video. So shout out to my friends, my fellow instructors. But with that, it's time for a Center for Education. This quiz was the death of me. Oh, Patsy, you got it. I know you got it. You ready? Let's do Center for Education. Let's do this. Now the quiz version of this is really nice. If you take the quiz version of this question right here for the Center for Education, here's what I would do. We're going to have to do a trick right here. You ready? Unusual features question. That one's a bit weird. Unusual features are things like outliers and gaps. Like imagine this is the scores of students, and if someone scored like a 700, that'd be unusual because it's like far away from the rest of the data. So the definition of an unusual feature is usually something that is not like the rest of the data, usually an outlier created by a gap in the data. So if this went 535, you can't see over here, 535, then went 700, the 700 would be an unusual feature, Alex. Does that make sense? Like that's really something unusual about this data set, that everyone's kind of all around 2, 3, 4, 500, and then someone made 700. They'd be a very unusual point because there's a gap between them and everyone else, and then they're an extreme outlier. So that would be an unusual feature in the data. Unusual features are usually outliers created by gaps. No, the data's already in order. It's so pretty right here. And we scroll down a little bit, and guess what? Here's a cheat. Right here, there are, I think, 22 total observations. So you can actually use this to figure out Q1, and Q1 is going to be right about inside of here. So Q1 is going to be... Ooh, can I find it today? Was it really that far over? The middle 50%? Really? No way. Oh, I guess it is. I believe that's it right there. And so that's 1, 2, 3, 4, 5, 6 in. 1, 2, 3, 4, 5, 6. So 498. There we go. You're welcome, Alex. That's a trick for this question. That is a trick for this question on the quiz version of it. Now, I would take these answers right here, and I'm going to show how to solve these. Let's show how to solve these. I'm just using the trick version of this, and then I'm going to show, if I could type, how to solve these. You ready? Here's how to solve them and do it by hand. First, we're going to copy to the clipboard. Copy to clipboard right here and hit Control or Command C. This is how to actually solve it. Now that we've copied to clipboard with Control or Command C, let's go over here and bring it into Jump. So we're just going to go into Jump and go to File, someone owning crazy amounts of pets, File, New Data Table. File, New Data Table. I'll pause. I'll drink some coffee. Good stuff. File, New Data Table. With File, New Data Table, we're just going to Control V to paste the data in. Now, what is the most important thing when finding things like median, Q1 and Q3? Our data needs to be in what? I think someone was saying it earlier. So Kaya said it earlier. What's the most important thing when finding things like the median or Q1 and Q3? If we're going to find them by hand, our data needs to be this, and this data is this. We could fix it if it wasn't, but our data already is this. What is the most important thing right here about finding Q1 and Q3, which our data would need to be in this? If we're going to look for a certain spot in it, for Q1, Q3, or median, put the data in order. Jessica, great job right there. Some points, Jessica. Put that data in order. So now that we have the data in order, here's how to find the position of the median. The position of the median is the amount of data you have plus 1 divided by 2. This is not the median. I did make a mistake yesterday. It's the position of the median. So the position of the median is the 11.5th number. There is no 11.5th number. What do you suggest I do to find the median now? There is no 11.5th number. Remember, the position of the median is, write this down if you don't have it, how many numbers do you have, 22 numbers, plus 1 divided by 2 to find the position of the median. That'll just find where is the median, not what is the median, but if they're in order, where is the median. So how many numbers you have plus 1 divided by 2 finds where is the median. You can also visually check it to make sure you have an even amount on both sides. Add together, divide by 2, Cassie, you are right. We're just going to add these together and then divide by 2. If we could, oh my gosh. I think that's right, 471.5. That does look correct. Tell me if I'm wrong. So there is the median. And what other things do we need for the 5-number summary? This looks like a low number. That looks like a high number. That is the median. What else do we need for the 5-number summary that I'm missing on the screen currently? We're talking about this day in class. What else do we need for the 5-number summary that I'm missing? The 5-number summary, which is on the screen right here. We need the min and the max. Great job following along right there. We need the min and the max, which are easy enough to see from this data set. 256 is the lowest value. 535 is the highest value. Then we've got the positions. Now the IQR, can anyone solve the IQR? It's just this distance. The IQR is just a range of the middle 50%. Q3 minus Q1. How far are these numbers away? So how far are these numbers away right here? How far is this number from this number? It's just the distance that these numbers are away, the range of these numbers. So there's the middle 50%, Q1 to Q3. How far are those numbers away? And that's oftentimes how we ask test questions. Like we show you data and we say, like, what is the IQR? So you have to know I have to look at Q1, Q3, just find out how far they are away. So the range of the middle 50% here. Ah, yes, Cassidy. Doing that here in a second. Great question. So 68. Great job, Jessica, right there. And more points. Just keep those answers coming. Everyone, great work. I told everyone I felt a little bit bad about my class yesterday where I felt like it just wasn't hitting the mark on educating. And this is what I love right here. I do not have this question yet. Elizabeth, ask any question you want and we can do it. We've got open questions after visualization 2. We got lots of time. So just drop a question you have right now. Be like, hey, Brian, I have this question. And then we'll put it on the list and we'll be doing it here soon. So, and also someone was saying, how can we find the standard deviation? Well, the mean is going to be all the values added up divided by 22 because there's 22 observations. On the test, we might have to do it that way by hand. But today we have JUMP. On JUMP to find mean and standard deviation, here's one of the best ways. Go to Analyze, and we'll even zoom in for you so you can see. Go to here to Analyze and go to Tabulate. Go to Analyze and Tabulate. You must make sure the data is quantitative, which it's blue, to make sure you're doing it properly. A few people have had categorical data. If you see issues, email me, Discord me, say, hey, Brian, my thing's red. I don't know why. But it should be blue, meaning quantitative. So let's calculate these summary statistics right here on the Analyze, Tabulate. I'm going to take column 1 right here and just drag it right here. So small error house, you got it. We'll put that on the list. You got it. And then check this out. Mean and then standard deviation. I'm just dropping it right there below it. If you have trouble, you can just replace things. You could just make standard deviation right there. You can just replace by hovering over. And just try using this right here. If you get like this, just don't worry, just keep replacing and you can get the values. So it's a little tiny box to add it onto it. That little tiny box appends it on as another thing. So there is the mean and there is the standard deviation. Do not work those by hand. Do know how to find the mean by hand. Do not ever learn to find the standard deviation by hand. It's not a good utilization of time. The mean is the sum of all the values divided by all the amount of values. The standard deviation is a standardized distance from the mean. More important to understand what a standard deviation is. Yeah, that's a good question. No, you can use JUMP on the quiz at all points. You will be using it a lot more. Patsy, and great work. Good practice right there. And great job, Patsy. More points. Sorry. This makes it really easy to find them. And then we can just get the answers of 453.1. As long as we learn to type things correctly and not make typos. We do make a lot of typos here. And then 69.3. JUMP will make some of the hardest quizzes in this class way easier. JUMP will make some of the hardest quizzes in this class take 5-10 minutes, where some people might be working problems for 2-3 hours. JUMP will make some of the quizzes that seem way hard very easy because we can just find answers. Like in truth, if I wanted to find a confidence interval for this data, I could go here to Analyze Distribution, and if it said find a confidence interval, I've already found the confidence interval. There's the 95% confidence interval. So if a question said make a 95% confidence interval for the distribution, I could say like, there it is right there. And I don't have to do barely any work. I just a few clicks and we got it. For the question where the middle 50% falls, correct. Q1 to Q3 is the middle 50%. Exactly, Cassie. Good answer right there. So determine if the scores are symmetric or skewed. So let me show how I would do this. I kind of did it by accident. To determine if it's symmetric or skewed, I should make a what of my data. How would I determine if my data is symmetric or skewed for univariate quantitative data? How would I determine if my data is symmetric or skewed for univariate quantitative data? Say, Brian, you should do this. If I want to do it for univariate quantitative data, which is we talk about shape, center, spread, how would I look to see if it's symmetric or skewed? Brian, make of this. How would I investigate if it's skewed or not? I should probably make of this. So we got answers on screen. Not quite got good answers right there. Don't worry, 100 points. Or I clicked both buttons. You guys got 150. Histogram. So scatter plots are for bivariate, for two quantitative variables. So don't worry, good answers right there. We'd make a histogram. Histograms show us the shape, center, spread. And so we'd go here to analyze distribution, which shows us one variable. And we're just going to double click the variable and click OK. That was analyze, distribution, and then choose the variable and click OK. I'll repeat the steps once again. Analyze, distribution, double click the variable, and then click OK behind my head right here. And so I usually stack it, and it's pretty clear to see that this monster man has a tail going in what direction. Our monster man has a what tail? His tail's going towards the what side? Not that monster man, this monster man. So monster man here has a what tail? Monster man right there got a what tail? Going to the left, Kai right there knows. Great work right there. You know, we haven't been doing this lately. We've been forgetting it's Wacky Wednesday. I'm sorry, Crash Man. We've been forgetting about you on these Wacky Wednesdays. Wacky Wednesdays. Afternoon class will definitely have me not forget. I make too many things and I forget what I've made. That was the first class. I made up like themes for every day. There's only 4-day themes. There's no Friday theme. Sorry. So that is a left skew distribution. Mine does not look like that. It is bimodal. It might be, if you're doing the same question, it's probably going to be same like mine, like left skew. He is old. Crash is old school. This is, so none of these say bimodal. Yours, you might be doing a different one, which might have bimodality to it. So it's skewed because they're not approximately equal. I think it's good. Did we just do the whole question? Please am I doing it wrong? Woo! Get so scared right there. Get so scared. Don't be scared. We got this. Cassie, did yours turn out? If you're doing the same question, it's probably going to have a skewed shape to it like mine right here. But great work right there. We have time, a lot more questions. I think someone else wanted another question. My YouTube chat fixed itself. Small warehouse, Elizabeth said. So let me add that to the list, Elizabeth. Small warehouse. And is that, I think it's one of these questions. We're going to talk through some visualization too. So let's go back here to the main screen. So visualization 2, you're welcome, Shira. You're welcome. Drop another question in the chat if you got it. We've just got a few more left. So, and remember, anytime you come to office hours, just say like, hey, Brian, I'm working on this question. Just drop it in at any time. It's the number one way to get your question answered. Because lately I've been going, you should see in the background here, as people ask questions, I put the question on the list and I take a note of it. So I've been trying to take better notes when people say like, hey, can you do this question? I then add it to the list. Can you do, you bet, Morgan right here. Morgan, let's make Morgan a mod. Morgan earning everyone 100 points, doing exactly what we want to do right here. BAS 320, that's on the list now. Assignment 2, question 3. Morgan, that is on the list. It'll be coming up here soon. And the rain, no rain. Rain, no rain. Coming up here in a little bit. Okay. I want to make a thing where it appears on the side. Be like, look what's on the list coming up right here. Things I need to create. A lot. Let's check it out. Yesterday was a great day. I really want to hit a home run every day I teach. Kind of my goal. And I didn't hit home runs. I'm still beating myself up over it. Gotta stop beating myself up. Adam's meeting with me tonight, and we're gonna make a really great video. It's one of my strengths is making good content, I would hope. Well, you know what we're about to talk about? We're talking about some diamonds. What's that song, Diamonds? Man, it's like everything I listen to is like old now, like Rihanna, like Umbrella. It's good stuff right there. Did Beyonce sing Diamonds? I don't know. Let's over to the main screen. Let's check this out. Here we go. It's time for some visualization 2. And the timestamp on visualization 2 is going to be 26 minutes in. Stat tool on visualization 2. So here we go. Visualization 2 is about displaying univariate visuals. So if you're not in our class, you might not have seen this graphic right here, but Rihanna was Diamonds. She is great. Rihanna is excellent. Check out all those univariate visualizations up at the top right there. Ah, awesome. Yeah, that's such a good song. Oh, she did sing that too. She sang Umbrella and Diamonds. Amazing voice right there. And so you have the univariate visualizations up here. I love that song. Let's download the data right here and check it out. Now, if you don't have jump, contact us immediately. Notice how the icon down here in the very bottom, it's a little hard to see, shows a jump icon. It shows a little spreadsheet icon. That means you have jump. If you don't have jump, contact us immediately or run to a library computer. And if someone says, what are you doing? You're saying, I'm running to the library to use jump. And they say, oh, of course, you're in Stat 201. I understand. It's a very common thing. We're going to let it open right here. It's just a little bit confused, but that's fine. So now we have the data set. This kind of looks like a different program, though. What program does this kind of look like to you that you've maybe seen before? I'm just making the columns look a little bit nicer right here. What program does jump often look like to you? If you said, that looks like another program I have on my computer, what kind of other program does it look like to you? We just want to get an idea. It's not so scary if you think about it this way. It's not so scary if you think about it this way. Does it look like any sort of other program on your computer that you'd be like, it's not so scary. It just looks like Excel. Great job right there. It just looks like Excel. It's good old Excel right there. I like that for 100 points. Good old Excel. So here is the identifier, which is unique for each and every diamond. What diamond do you want currently on the screen? Here, let's do this right here. So many different clarities of diamonds. What diamond I will give you. Let me sort by this and see if we get an interesting. I will give you a diamond on the screen. Say, Brian, I would like this diamond. I will identify that diamond. Pick a diamond out for yourself. Interesting class all of a sudden. Pick a diamond out for yourself. What diamond do people want? You can identify the diamond with the identifier, which is unique for each and every observation. Just kind of remembering what an identifier is. Now, we don't graph identifiers because, frankly, and you wouldn't want to do this, identifiers, if you graph them, would just look like this. Because they're unique for every. There's no repeating of identifiers. This is not a good. Do not do this. Do not make this graphic. No one wants a diamond? Free diamond's gone. So any diamond you pick, like if you say I'll have diamond 299, I can tell you all about that diamond. That diamond is 1.01 carat. It is a very good cut. It is color H, clarity VVS2. I want 444. Oh, I bet you were very smart on this. Did you? Let me go find diamond 444. Kaya, I bet you were very, very smart. Kaya wants 444. I can identify that diamond. Kaya went, good choice, Kaya. Good choice. 100 points, Kaya. Very good choice. It's only a carat. It's only a carat, but that's an expensive diamond. About $11,000, exceptional white. It's a strong carat. It's a strong carat right here. Very good cut apparently. $11,000 diamond. 396 pocket change. Just pocket change. Not for me. Rare white. There we go. Just people are choosing around a carat. I think people were actually taking the time. Oh, yeah, we're doing that here coming up in a moment. John, you got it. That's on the list. Thank you, John. 100 points, John, right there. We're just going crazy on the points. So we can identify the diamond and see what's going on. So what's the point of this? Well, we need to visualize some of this data. Now, here's the thing. I usually work in a different data set, so I don't do the exact same thing you're doing. Please use the variables it says. Please use the variables it says. Do what it says. I try to use data sets you do not have or would not be using, like the Stat 201 survey. So you are doing a different data set, but the number one thing you should do when making your visualization, as it says, is to just start out by doing a what? You should start out by taking a what? Sample. You should start out by taking a random sample. Random sample right there, Jessica. You know what's going on. We got this. We're going to start by taking a random sample. So this makes it unique to you, which don't send anyone your work, whatever you do. Not saying you would, but don't do that because everyone's going to have unique random samples. So to take a random sample, and this is the first assignment again, We go here to tables, and then we go to subset. I'll pause right here. Table, subset, tables, subset. Now we put in on the new window 300 plus the last two of our UTID. That's mine today. 300 plus the last two of our UTID, and we hit random sample size. 300 plus the last two of our UTID, and then click random sample size. That's going to take a random sample of 353 from the data set of 806. Make sure to use your last two of your UTID. Do not do exactly what I'm doing right here. I'm just putting in my last two digits, 300 plus the last two of my UTID. So now you can see we have this. Make sure to keep this, and when you're working on the assignment, and this is the one you will use at all point, this is the rows you should have, 300 plus the last two of your UTID. Now the first graphic we're going to make right here, so let me put a note. Let's see right here. Let's put a note and put a timestamp at 32 minutes in, stat tool 1, viz 2, and let's talk about a bar chart. If I have a bar chart, what kind of data am I visualizing? I know, like, you might be like, I want to do the visualization, but just tell me bar charts visualize this. Bar charts visualize this. One this. Bar charts visualize this. Bar charts visualize this. Because you could use a bar or pie chart. They're interchangeable. They would do the same sort of data. A bar or pie chart would visualize this. Bars or pie charts visualize categorical. Great job right there, Kaya. Bars or pie charts visualize categorical data, one categorical variable. Great job, Rudy, right there, and Jessica. So we go here and we go to Analyze Distribution. Analyze Distribution. Under Analyze Distribution, you'll notice some of these are red, and that means categorical, and some of them are blue, which means quantitative. The identifier is actually blue. Don't worry about it. It's still an identifier, but for some reason it was marked as quantitative, but don't worry. It's still an identifier. Don't visualize those. So we're going to take something like, let's take how far people are away from campus. And then we can just drop that right here under the Analyze Distribution platform and click OK. Now we have a bar chart. It kind of looks like a histogram, but be careful. This is a bar chart because it's a categorical variable. Go to this red arrow right here. We'll zoom in so you can see a little bit better. Go to the top red arrow and click Stack. That'll put it in horizontal layout. The top red arrow stack gives us the horizontal layout. Next, we need to go right here and click the second red arrow, not the top one this time. And it does say histogram options. I know that's like super confusing. I don't know why Jump does that. It's a bar chart, I promise you that. And so under histogram options, I know. Go here to show counts. That'll put the counts on top of each group. I'm also going to adjust the axis a little bit right here so it doesn't look so crazy. Really, Jump? Really? There we go. I don't like that the values are off the screen. I want to make this look all pretty right here so that we're like 10 times a day, but we got to make sure it looks pretty. And so there we are, looking a lot better. I'm going to do one last thing. I'm going to go right here and go to histogram options and go to count axis. There it is. So these are the options I have clicked. I've kind of adjusted. You could even go really specific and double click on this and make all fine adjustments, but there's a lot of options you can do in Jump, so don't worry about it. You can even change the way it's oriented. I could change the size of the text, all different things, but I'm going to leave it at this. This is a bar chart of people's distances from campus. Can we do, yeah. But tell me if it's the quiz. Which question are you working on, Cassidy? Because remember, they mix up on the quiz, so you'll have to be like, it's this one. So tell me which one, Cassidy, because we do have enough time, I think, to get to that. Yeah, we'll get more than enough time. So tell me which one it is, and then we'll go find it. So with this right here, what do you notice about most students? Like, if I'm to talk through this, if I'm going to explain this to someone, I'd probably say most students at UT, which accounts for 32.57% of students, or 115 of them, and this is what I would write up. Most students at UT, 115 out of the 353 I sampled, do what? And this is what I'd be writing. Most students at UT, 115 out of the 353 that I talked to, which represents 32.6%, were students who live where? So look at my data. And so I'd say most students, 115 out of the 353 were students who lived where? So look at my data. The fort. Exactly, Kaya, right there. And then we'd say the second most common category was about oh, you got it. Yeah, next size. Let me put that on the thing. The second most common category would be what? The second most common category for people's distance from campus were students who lived where, which represents 109 students, relatively 30.9% of the students out of the 353. Notice how I'm mentioning the numbers while talking about this, and I'm just talking through the different groups. I might mention all of them to say the third most common is this, the fourth most common is this, and the least common, only 2 students, about 0.5%. Exactly, Jessica, right there. So does that make sense when we talk about like interpret this right here? When we talk about interpreting the graphic, you need to mention the numeric values and pretend that someone can't see these. Or like John Cena right here, you can't see them. My jokes are bad. So you can't see these numbers, and you have to explain somebody the numbers to give context to what they mean. So you want to talk about these numbers as though someone can't see them, and make sure to mention them and talk about the most common, the least common, just maybe go through and list the groups, but just explain the data to somebody. And that's what you're doing right here in the visualization assignment. Create a bar chart of cut using analyze distribution, include the values, either at the counts or the percentages, which we did. Take a screenshot of the output. So when you take a screenshot, make sure in your screenshot that you go right here and take the screenshot something like this. That'd be a good screenshot. Make sure your screenshot looks nice and professional. Don't take a screenshot that looks something like this. Don't do that. Don't do that. If you're ever wondering about your screenshots or you get points off, let me know. Some people do lose points on the screenshots. Next, we have creating a pie chart. So let's put a quick cut in the video right here. So let's put, we're at the 3740 mark. Stat 201, Viz 2, pie charts. So pie charts are also going to be univariate categorical data. So interestingly enough, everything we just talked about for this visualization right here is kind of what we'll be talking about for pie charts. So let's do this. Let's go to Graph Builder, and I'll pause on the screen right here. Graph Builder. Under Graph Builder, we're simply going to take a categorical variable that it tells us to take, make sure to use what it says to use, and then we'll put that categorical variable, like distance from campus, inside of here. Then we'll click the pie button. So let's go and click the pie button, and we got a pie chart. Now, don't take a picture of this yet. Don't take a picture of this. Don't do that yet. No picture yet. No paparazzi. We need to go here and add labels, and I would probably add the percentages. See, now we can see actually the percentages a lot easier, and then no picture yet. Don't take a picture yet. Click done. Now you're going to say, I'm going to take a picture. Don't take a picture yet. I am probably going to adjust this. It's all right if you made it a little bit big. That's all right. But now, that's a good picture. Always, I don't know. I'm a perfectionist. I want things to look really good. So I'm always like, how can this look really great? What could I do to this to make it look exactly the way I want it to? You know, how do I want my picture to look? And I think this is going to be the optimum picture right here. There might even be additional things that I haven't seen, tons of buttons to click, but that is going to be my optimum pie chart. And I think it goes without saying, there's our picture. Whoops. The interpretations right here. How do you think? Yes, Shiv right there. Good question. Help me put that on the list, Shiv. So, what do you think I could write as a sentence to interpret this? What do you think I could write? So, what do you think I could write as a sentence to interpret this? Who could write one sentence of interpretation right here for this? Try to take a moment and write one sentence of interpretation on this. One sentence of interpretation. Give me one sentence to interpret this. Now, don't just write one sentence. Interpret this fully. But how would you start an interpretation on this? How would you start interpreting this pie chart right here? Now, make sure to mention values. So make sure to talk through the values. We got a pie chart that shows the percentages. Nice, neat graphic. Good screenshot of it. How could we just write one sentence to interpret those values? Just start by writing a sentence. And then write some more sentences. But make sure to mention the values. And how would we start with this? What would we say to start? So just think all you want to do is talk through the numbers as though someone can't see them. Like they can't see your pie chart and you have to explain it to them as though there's the values. Like, what would you say? Would you talk about, like, how would you start off at telling them about this pie chart? So that's whenever we say interpret, you always be like, let me give the numbers context. If you retake the quiz, does the, yep, great question, Cassidy, the highest grade counts. So if we want to talk through this, we'd say something like 30 point, or let's start with the highest group probably. The most common place for students to live was in the fort, which was 32.6% of the students we spoke to. The second most common place for students to live was 30.9% of students living on campus. You could go down the categories talking about the next was this. The least common group was students who were 30 plus minutes drive away from campus, which was 0.6% of students. So make sure to give those numbers context and make sure to mention the values. Now, probably the toughest one right here is going to be the histogram. So when it comes time for the histogram right here, I'm putting another note right here, the histogram, 41, 45, Stat Tool 1, Viz 2, histogram. So on the histogram, the most important thing to do when we do histograms, besides making the visualization look awesome, is to know how to interpret quantitative data. Histograms are no longer univariate categorical. Histograms, box plots, stem, and leaves, as you can see up there in the top left corner, are univariate quantitative. Univariate quantitative, all those graphics go together. Univariate quantitative. So univariate quantitative displays of data's histograms, box plots, stem and leaves, dot plots. My accent's not that strong. And so let's go back to our data and take a look at this. So when we analyze and go to distribution, we will get a univariate display of data. That's what analyze distribution does. It displays one variable at a time. So let's go to analyze distribution. And we can do something like, let's go to number of pets people own, like we did today in class. This distribution right here is very, 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 very what? And so I want to point out, I'm going to go to the top right arrow and go to stack like we did previously. I'm going to go to the second right arrow. I'll do it a little bit slower. And tell me about this distribution as I do this. Histogram options, count axis right here. Yeah, no, that's, Aaron, that's what we're doing right now. Yep. And I'll have the timestamps in the video. We're talking about visualization 2. We're on histograms right now, Aaron. So let me know if you have questions. We're showing how to do it right now, and you can actually rewind this video live. And Kaya's right there. This is very skewed, and I'm adding the option to put an account access, and I'm just making this look a little bit bigger right here. So now we got a really nice picture. So the number one thing, and Kaya, you got it. You're welcome, Aaron. Perfect time to join in right here. Aaron, some points. Thank you for asking. So the number one thing we do when we look at univariate quantitative data is we identify the what of the distribution first. What's the order? The first thing we talk about is the what. So we put a count axis on that. I don't think it says display the values above it, but we always talk about the what of the distribution. This here must be in horizontal layout, have a count axis. Yeah, we got it. We're good. We identify the shape, Kaya. Great work there, Kaya. We identify the shape of it. So with the shape of it being identified, now we know the proper center and spread. Because, and we were practicing this today in class, I'm hoping everyone gets all those points, Jessica and Kaya. Great work right there. Because it is skewed, what is the proper measure of center? Because this is skewed, what is the proper measure of center? So this right here is skewed. Because it is skewed, what is the proper measure of center? The median, exactly. Now, will you say the median is this? Will you say the median is this? Skewed looks like that. Will you just, is that how you would talk about the median? This is normal data. Normal looks more like this. Will you say, because let me see what the thing says. Let me look at the grading key. So report only the appropriate measures. So it says, does it say interpret them? I wish it said interpret more. We're down here on the bottom. Visualization was created with all the required data and output includes, so you need to report only the appropriate measures. So I guess you only have to report them if it's skewed, median, and IQR. If it's skewed, median, and IQR. And look, right here we have the median. Oh, we don't want to use that color for it. Right here we have the median, and right here we have the IQR. The IQR is 2 and the median is 1. The IQR is the range of the middle 50%, and based on the shape, we determine what is the appropriate measure of center and spread. Notice once again that when you are talking about mean and standard deviation, they're paired over here, And when you're talking about median and IQR, they're paired over here in this output, like they're next to each other. So it kind of gives you hints when you look at the output to be like, oh, mean and standard deviation are next to each other. Mean is the center, standard deviation is a measure of spread. Over there in the other data, median is the center of skewed data, the proper measure of center. So make sure to only report those. Now, here's what I would say for this. The 50th percentile of pet ownership is represented by the median, which is one pet being owned. The IQR shows us the middle 50% of pet ownership, which has a range of 2. The IQR shows us the range of the middle 50% of pet ownership, which has a range of 2. Do not, if you have data that is skewed, do not use the mean and standard deviation because those are heavily impacted by outliers. So notice what it says right here to make sure you get full points. Report only the appropriate measures of center and spread. You might even say something like, the appropriate center for my distribution is this. The appropriate spread for my distribution is this. Make it clear to the grader you know what's going on, but make sure to only, as it says right here, only. Now I want to point one last thing right here. I want to put one last segment of this video, and then we're going to do the small warehouse question next. Does it automatically show the count access? It doesn't. Alexa, great question right there. To get the count access on a histogram, go to the second red arrow, go to histogram options, and go to count access. So to get the count access, thank you, Alexa, for asking that. Go to the second red arrow, go to histogram options, and then count access. You have to go to like in a sub window. So you'll click this red arrow here. You'll hover over this, and then you'll go right here to count access, and that'll add or remove it depending on if you've already clicked it. Now we can put the count access back on. So make sure to add that in right there. And the horizontal layout is found right here under the stack. There's a horizontal layout button too, but stack also does it. One of the quickest ways I found is just go horizontal layout and everything goes horizontally. Much easier. I don't know why they don't do that by default. Alexa, let's make you a mod right here. Thank you, Alexa. Keep asking those questions. I'm going to throw a few more tips and tricks here, but remember, it's your questions that guide the discussion. So if you're ever wondering anything, let me know. So Viz 2 tips. Big advice. Let's put big advice. Okay. So here's my big advice. After you're done making your visualization, what should you look at? Remind yourself again, after you're done making your visualization, what should you look at? So after you're done making your visualization, what should you look at? After you're done making your visualization, you should totally look at this and then just go through point by point on it. So what should you look at after you've made your visualization? This is a great way to ace things. After you, and like on the project or visualizations, for anything we have one of these for, what should you look at after you make your visualization? You should always look at this. Just want to make sure people might know the rubric. Jessica, 100 points right there. You should look at the rubric. Check out the rubric. Did I put my name on my document at the top? Did I put my name on the document? Next question. Did I take a random sample and use it throughout the assignment? So next, bar chart was created with all of the required elements like labels, output, blah, 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 blah. Pie chart. Pie chart was created with all of this right here, and then we went through and did the short write-up. So you can see it's right here. We have a short write-up. We have the short write-up using the information, and we have the histogram. So go through, yeah, of course. Activity question 8. Yeah, we might have enough time. Yeah, I think we might. Kayla, let me put that on the list. Thank you so much for everyone joining in and asking all these questions. We got such a good list of stuff today. So I'm working through, and thank you for everyone answering questions too. Activity 2, question 8. Good stuff. Visualization 2, really great help right here. Let's do the small warehouse question. Huge shout outs to everyone in the chat right here. We're going to get the warehouse question up and going. I think we got just enough time for everything that we have listed. And just jump in whenever you're here and just ask a question. We can probably get to them. We'll just do our best to work through as many questions as we can. And big shout outs to everybody who's answering questions, following along, good practice. I will say this, a lot of the people I see watching live. Oh, wait, do we have the waist study? Was it the next size one? There was the next size question. I love it. The next size one, I'm going to jump the line on the next size question. Wait. Because I found the next size. So here comes the next size question. But if you're here watching live, you're learning a lot. I see a lot of people do really well who watch live. So big shout outs if you're watching live. So 50... Stat 201, Chapter 2 quiz. All right, next size question. Okay. I really like this question. Let's go check it out. Here we go. Next size question. Let's do it. I just happened upon this question, which is in our list of things to do. Oh, love it, Jessica and Kayla right there. So when you look at this data, we can use some tips from what we were just doing. So we were just working on the visualization. How does this data look? Does it look normal or very skewed with outliers? Just kind of go for a central idea of it. Go for a central idea of it. Does it look normal or does it look very skewed with outliers? Like, which of those would better describe this? Kind of normal, like unimodal symmetric. That's what I mean by normal. I'd agree with Cassie right there. It looks kind of normal to me, right? Like, kind of like, wait, aren't these outliers? Sometimes people have a little bit bigger or smaller neck size. So I would say because of that, what should we use? And we might still have our picture. Oh, look, we still have this up from the perfect question. What should we use because we're saying it's kind of normal? Now, the one over there is skewed, but since this looks kind of normal, what should we use for the center and what should we use for the spread respectively? So center would be this, spread would be this, mean and standard deviation. So this is a really good, like, going off of, okay, that looks kind of normal, the shape's kind of normal. So the mean and standard deviation, because it is unimodal and symmetric, because they're talking about the shape right there. So that's got, oh, that's a good question. That's a really good kind of making sure you know that the center would be the mean and the standard deviation would be the spread. And we got some really good review right here from when we were practicing the visualization, talking about what would be the proper measure. And the shape dictates the proper measure. First, decide the shape of it. And then if it's skewed, use median and IQR for center and spread respectively. And if it's not normal, or if it is normal, use mean and standard deviation. Cassidy and everyone, great work. Alex, great work. Really good kind of quick question. I guess does this make sense right here? Make sure to have your flashcards. If data is skewed, the center is the median. If data is skewed, the spread is the IQR. If data is normal, the center is the mean. If data is normal, the spread is the standard deviation. Mean is a measure of center. Median is a measure of center. Lots of things like that. Just things we need to drill our mind on to practice. What you doing? Selecting the wrong answer right there. Let's head back here to the main screen. We'll do the small warehouse question. Let's do this. Cassie, thank you so much. It's good practice. Cassie, I want to throw a big shout out, 100 points. I think a lot of people don't realize, like, we just have to, like, practice these things, and then you get it down. You're like, oh yeah, mean, standard deviation, median, IQR. It becomes second nature. It's weird for me because I've been doing these topics for so long. I think sometimes the toughest times to teach stuff is when you're first learning it and you're trying to get a deeper understanding. I've ran into those situations. But then it's also harder to teach stuff when you really know it. Not that I really know anything, but if you really know things, sometimes you're like, well, then it's obvious. Like, imagine trying to teach a child what 2 + 2 is. You're like, well, it's 4. and if you try to teach me, like, chemistry, you're like, Brian, of course, the covalent bonds of something, I'd be like, I don't understand what covalent bonds are. I just made up that word. Like, it's not a made-up word. So I think it's harder kind of when you really know something or when you don't know it. Because if you don't know it, you're struggling for the words. But if you really know it, then it doesn't make sense how to not know it. So you want to be in that happy range where you've learned it, but you maybe can see where people are trying to learn it. I guess same person and then eventually know it. Yeah, I know this. Oh, thank you. And that's my goal, is to try to, like, present things different ways. Thank you, positivity, love it. I try to come at it from different ways of teaching it. Me and EB406 right now a bit of a struggle. Jessica, great work right there. And actually, Jessica and Kayla, I don't know if you guys, wait, is that, we got a bunch of Kaylas here doing mathematics. Upper level of mathematics. Jessica, shout outs to you right there. What is Math 405? Math 405 just sounds tough. You put a 400 level math anything, that just sounds like it's gonna, whew. 400 level math just scares me right there. Models in biology. Yeah, you say, Brian, it's obvious. Come on, Brian. I would know none of it. It's funny to me. Help, Professor just joined. I was wondering if you could, or how to calculate Q1, Q3. We might be doing some of that right now. Let's do that with this question right here. So questions on Q1, Q3, and standard deviation. Good questions right here. Let's actually use jump for this question. So Vinny, good questions, Vinny. We're going to answer your questions, Vinny, on how to calculate Q1, Q3, and standard deviation with this question right here on the small warehouse question. Vinny, great questions. Thank you so much, Vinny, for joining in. So what I would do right now is I would have jump open. Now this one actually doesn't let us copy the data. Sometimes there's a little button over here. I'll have to show it by going to another one where you can go right here and go to copy to clipboard. So this will allow you to just copy and then paste the data into jump. If you can use this, well, you won't use jump on the exam, but you will look at jump output probably on the exam. So you won't use jump on the exam. You will look at jump output, or basically what we're doing right here, and I want to show you, I'm going to go here and go to File, New, Data Table. So I'll pause right here. I'm going to go to File, New, Data Table. And I'll explain why I'm kind of using jump, but I'm kind of not using jump. File, New, Data Table. File, New, Data Table. Kayla, great work right there. Under File, New, Data Table, here's what I'm going to do. There are let's go with the 6 stock boys. The 6 stock boys. Now tell me, am I really utilizing jump right now, or am I just doing what? Am I using jump really right now, or am I merely just doing what with my data? It says there's 6 stock boys. So there's 6 stock boys. Am I really using jump right now, or am I just kind of doing this with my data? So am I using jump like for its full intended purposes right now, or am I more of just doing what with my data right now? Because there's 6 stock boys. So am I utilizing jump to its fullest power right now, or am I more just using it to this, my data? I'm just listing my data, right? I'm just writing it down. I'm just making a list of the 6 stock boys. I'm going to put it in order. Great job, Jessica, right there, and Kayla right there. I'm just going to write down my order or my data. I'm just organizing my data. So now what do you think I'm going to do next? Tell me, Brian, you should probably do this next if you're going to write down your data and jump inside of here. So there were 6 stock boys, and I kind of want to do it in order here. What should I do next? So what do you think I should do next? There's 6 stock boys. Gosh, my New York accent just gets stronger as I get older. The further away I get from New York, the stronger it gets. If I go to like Japan, I'd be like, hey guys, how you doing? I'm from New York here. Don't send me to Japan ever. Separate the drivers and the stock boys. Yep. So let's take the drivers right here. Here's the 4 drivers. Does that make sense? We have 4 drivers making $500. That's driver number 1, driver number 2. Exactly 4 drivers at $500. We have 1 inventory manager making $850 a month or a week, and we have 1 supervisor making $1,200 a week. Which is $480 a week. It's like $2,500 a year, $25,000 a year. Go Yankees! Nice, are they ready? So with this question right here, we can now actually find some values. There are 12 values right here. Who remembers the formula, 100 points in the chat, to find the position of the median? To find the position of the median, how do we find the position of the median? The position of the median would be found how? Just to find the position of the median. Now, I could divide this into 2 equal data sets to see that the median is there, but how do we find the position? It's kind of a decent formula to memorize. Like the position of the median is the amount of data you have divided by... So you can find the position of the median by doing the amount of data you have. Then what do I do next? Plus 1, divide by 2. That's the position. Exactly. So do the amount of data you have plus 1 divided by 2 to get the position of the median. That just tells you where the median is at. So what is the median? Who knows what the median is here? Take a moment and see if you can solve for me the median. I'm kind of showing it visually on the screen. Can you find the median? So if you wrote down all your data in order, you'd say the median is at position 6.5. There is no position 6.5. The median is what for the data right now? Because there is no position 6.5. So what is the median? So you can kind of do it in your head right there if you think about these numbers. The median would be what for this data? The median would be what for this data? It's right there. It's not on the screen. The median is not currently showing. The median is not visible. It's in the 6.5 position. 490. Kayla, great job earning 100 points. You got it, Kayla, right there. The median is 490, which is the 50th percentile of wages. No, you got it. Don't worry. Answer away. Don't worry. Don't worry. I don't mind. It's good practice. And so now here's the tougher part. What would we have to do to all of our data and then divide by 12? So I like to ask smaller questions a lot of times. I've learned that's really great for getting answers. What would we have to do with all of our data right here and then divide by 12? We'd have to take all these values and what them up and divide by 12 to get the mean. So you'd have to what all these values right here. So you could do this in a calculator. You'd be like 480 plus 480 plus 480 plus, you could times it by 6. So you could take all these values and what them up and then divide by 12. Yeah, I think so, Cora. Yeah, Cora, we should do that. I know you asked about it yesterday. Let's try to do that. I'm going to try to put that on the list. Cora, we're going to jump the line a little bit on your question because I know you mentioned that yesterday. I'm going to put that right here, and Kayla, we're going to try to get to yours too. BS for 75 assignment 5C and D. Thank you, Cora, for jumping in and asking that. We've done a lot of 201 today, so we're going to try to get to that. So we'd have to sum them up. Kayla using some terms right there. I know, Kayla, don't worry, you are so helpful right here. And like, enjoy. That's what we want. We just want people interacting. That's what makes this enjoyable. So we can find this a lot easier with the analyze tabulate. So Vinny, this goes to your question right here. If you have your data in JUMP, go to analyze tabulate. Analyze tabulate. Under analyze tabulate, take your column and drop it right here. So we're just putting it right here. Just the column goes right here. And then you can find the mean just by doing that. You can also find the standard deviation just by doing this. So under analyze tabulate, you can find the mean, the standard deviation. You can replace it if you want. If you have issues with it, just kind of restart it. If you have to go really right there to append onto the list. But you can find the mean, the standard deviation just like that. We could have even checked our median. Is there a median? There should be a median on here. So I do there's the median. I know I don't use it that often. I should use it, but you can get all of this right here. I'll show you something. Kel, I should show you in 320 how we can do it, because the things we can do in 320 are even crazier with the aggregate function. Like you can get tons of crazy statistics like that with aggregate. Aggregate is super powerful. It does this, but at an even higher level. I'll show later. So this right here, Vinny, is how we can get the mean, the standard deviation, all these values. Now, we'll never ask for Q1 and Q3 on the test. If this question asked for Q1 and Q3, I would do the following. What is Q1 of this data? Look at the lower portion of the data and tell me what Q1 is. The answer is it's kind of obvious. What is Q1 of this data? Q1 would be the median of the lower portion of the data. So what is Q1, which would be right here? I'm hovering over the position of Q1. It'd be at the 3.5 position. We don't find Q1 and Q3 by hand on the test, but Q1 would be there. And so find the lower 50%. It'd be 480. Great job, Vinny, right there. Another 100 points. Excellent work. And then the upper one would be, I have to make it small again. The upper 6 values are here. And the Q3 would be what? Q3 would be what right here? So Vinny said 480. And then Q3 would be what? We would not find Q1 and Q3 by hand on the test. Q3 is what now? Q3 would be what? Q3 is going to be the middle of the upper portion of the data. It's in that position right there. That's where Q3. If you divide the upper portion of the data evenly, that's where Q3 is at. I'm going to ask one more question after this, and we'll finish answering this one right here. Q3 is at 500. So remember, Vinny, you said 500 and 480. If I take IQR, it should be what? Tell me what the IQR should be. Remember, you said 500 and 480. So what's the value of the IQR, which is more important? This is what you'll need to know how to solve on the test. So Q3 is 500. You just did it. You just figured out Q3 and Q1 by being like the middle of the upper, the middle of the bottom, and then the distances they are away. Great job, Jessica and Vinny. 100 points for both of you right there. You just figured out IQR right there, finding Q1, Q3, and the distance those numbers are apart. Conceptually, these are the big things to understand. More importantly, this data, you can click right here, this data is very, very what data. Look at the visualization right here. It's a histogram. This is extremely what data. There's the 480, there's the values there. It's extremely what data. You can tell me which direction, but you might get tricked on that. This is very, very what data. Very, very what data. It is very, very what data. You can click the histogram button to see it. That is very, very what data. Right skewed, and great job, Jessica, right there, not getting tricked. A lot of people get tricked because if you drop this, you'd think it would be left skew. But remember, that tail is going to the what side? 4-letter word. If you drop it, it'll be reverse image, but his tail is going to the what side right now? Monster Man's tail is going to the what side? So don't get tricked if its number line would be reversed if you drop it. Right to the high, left to the low. We learned our lesson last time. Right to the high, left to the low, whatever way Monster Man's tail goes. Don't be tricked if you drop it and the number line's reversed. I just do want to mention this again because it's just a super common error to just drop it like this and say, oh, it's left skew, but you're your number line is reversed. You don't usually do number lines like that. You would have to mirror image it to see it in its proper format, where Monster Man's tail, if you go from the low numbers to the high number, it is right skew. So that kind of answers it. The mean is 577.5. And how many employees earn more than... Whoa. How many employees earn more than the mean wage? There's only 2. If this is the mean wage, which it is, this person and this person earn more than the mean wage because of the skew. Which is the best measure of center. Remember, center is either mean or median. So the median is the best because of the skew. The median is the best. The mean is not a good measure because it's affected by the 2 outliers. Exactly. Duplicates don't matter so much. Which is the best measure of spread? It's going to be the IQR. So that's literally the answer, because it's the IQR. So you can be like, it's the IQR. You don't have to worry. It's like, which is the best measure? The IQR. So because remember, median is always paired with IQR. So once you select median here for center, you'll select IQR for spread. Really good question, really good practice, and showing how to use tabulate for different types of questions. Let's head back here to the main screen. Let's see what we got next. We got assignment 2. So we're going to jump the line. We might be able to do the rain, no rain. I'm going to do the BS 320. I haven't done BS 320, but Corey, your question's coming up here after assignment 2, question 3. So let's go check this out right here. A little chill music right here. Let's go check this out. BS 320, question 3. Let me go get the assignment. Say, Brian, you're not prepared. I say, I'm sorry. Let's go grab the assignment. Some for loops. How is everyone's day going? Oh, I just downloaded the answers. Don't want to do that. Okay. Hey, Snea, good to see you here. Good to see you. Parker, great to see you. If we can't get to Rain or Rain, it's okay. We should do it. Lucy's here with you. That's awesome. Hey, Lucy. And you, I hope you both get to meet other Kayla. Was I talking to Snea or other Kayla about, we got so many Kaylas. We got Kayla G in the chat and we got other Kayla. But Lucy, hey, I hope you're doing great. I really want to go and see all my students. Snea was talking about seeing the Brian with the jacket on in the office, not the real Brian. My day has been nice. Kaya, so good to see you. Kind of sunny. Both Kaylas, everyone's saying hey in the chat. 100 points. Tell Lucy I say hey. She's heard me say hey like 10 times right here. Hey, Brian, says Lucy. Oh, that's so awesome. Very nice day outside. That's awesome, Vinny. That's awesome. Let's put the timestamp in here. I've started timestamping my videos live. It allows me to... I used to be spending quite a lot of time in the evening timestamping videos, and I was like, what if I do it live? And then I have better timestamps and spend less time in the evening. More and better timestamps. Let's go do BS 320, assignment 2, question 3. Okay, so here is for loops. Snea and Lucy, how important are for loops? You've joined in. How important are for loops? How important are for loops? All the shout outs. Cora's in the chat. Everybody's in the chat. Cora, giving shout outs. How important are for loops? Super important. A for loop allows us to do tasks multiple times very quickly. Now, when we do a for loop has how many parts to it? So a for loop has how many parts to it? Here, let's just view a for loop. And a for loop has how many parts to it? How many? Miles knows. Good to see you in the chat, Miles. So a for loop has how many parts to it? We can't forget about him. We can't forget about our buddy down there. He gets all mad and freaks out if we forget about him. So a for loop has 3 parts to it. Cora just on fire with those answers. Cora's right. A for loop has 3 parts to it. A variable, a vector, and a skeleton. The variable is just a placeholder. Placeholder for what changes in the skeleton. What will change as we run the skeleton right here? Just tell me, when you run this for loop up above, what will change when you run that for loop? You just have to practice your terminology, understand it like this. Maybe sometimes I'm teaching about Git and I don't know the terminology perfect. You got to practice your terminology. Got to know it inside and out. It's going to be word. Every time that for loop runs, it changes what word is. But you know what never changes? I mean, it probably changes over time inside of us. But what never changes right here? Code that runs each time that never changes. Every time this for loop runs, I'll give you a hint so you can copy paste it. The skeleton never changes, so every time this for loop runs. Yes, correct. Ruby right there. Exactly. Change it up and just repaste it in, then change your numbers. Ruby, good answer right there. Ruby, thank you for asking. Make sure to change it. Don't lose the points for losing the random sample. All the graphics will be based on your random sample, so we can kind of see you did the work. Not saying I think you did your work, but make sure to kind of redo them. Sorry. Make sure to use the random sample for all of them. So good question right there. So when we run this for loop, every single time, the skeleton runs the same way. Here's a quick question for you. When I run my for loop, don't tell me what this for loop does. Don't tell me what it does. What is the code that runs every time this for loop runs? Don't tell me what it's going to do. Just tell me what is the code that runs every time this for loop runs. What is this for loop going to run as code? It's going to print Brian, print Brian, print Brian, print Brian. It's not the word Brian, it's the object Brian. So that's not the word Brian, that's the object Brian. So John, good questions and answers right there. It's going to print the object Brian. The object Brian is the variable placeholder, which will change, and it will go through the vector. Values the placeholder goes through when it runs the loop. So how many times does this loop run right here? How many times does that loop run? So the vector is the values the placeholder goes through when the loop runs. So it'll go through the values 1 through 5. So how many times does that loop run right there? It runs 5 times. So think about what this loop does. The first time this loop runs, it's going to store into Brian 1. What will the loop do after it stores 1 into Brian? Now be very careful right here. This is where people make the error. We were repeating it and we were remembering it. After it stores 1 into Brian, which is what it does on this line of code, it will do what on this line of code now? Be very careful. Remember, the skeleton never changes. That's the key to the answer. The skeleton never changes. Oh, Galen, oh, you got 100 points. No, wait. It will kind of, I do understand what you're saying. We will see 1 appear, but what is it going to do? Oh, no, Miles. That's 100 points. Oh, you're fine. It prints Brian. So why is it printing 1 though? You are right. It is going to print 1, but it's printing Brian. But why is it? You are correct. It is printing 1. That is correct on what it does, but it is printing Brian. But why is it printing 1? Just explain to me. It's printing 1 because what? Brian is 1. So we are printing 1 technically, but we're actually just printing Brian. Does that make sense? So then what does the loop do next? When it gets back up to here, it moves over to the next element, and what will it do next? So we're actually answering the above question too right now. When it gets up to there, it's going to change the placeholder to the next element in the vector. Miles, you're on the right track. I haven't changed the code. You're right there. It'll do what? You're on the right track. Makes Brian 2. Then what does it do? Now remember, skeleton never changes. Your buddy right here, he's going to get all mad if you tell him he's changing. No, he never changes. He always does that right there. He does the same thing through that loop. He's in a loop of doing the same thing. It still just prints Brian. And then guess what? All it's going to do is just change what the placeholder is. Every time the loop runs, it does this. So there's the loop, but we don't have to do that like that. We can just run the loop. That's what it was doing in the background. It was changing what Brian is. Does that make sense? The loop just prints Brian every time, and it changes what Brian is. Let's use our knowledge. So don't include this. If you see me doing extra work, don't include it. I think sometimes people listen to these videos on mute and just copy down what I write. And then you see these things like this. When skewed right was represented as center spread. Yep, that is correct right there, Vinny. Good question, Vinny. Great answers also, Kayla. Thank you, Kayla, for following along. Good practice. Like, we need to know these things in 320, not joking. That's going to be big in 320 when we start doing associate functions. So you are getting lots of practice, and you'll be like, it's skewed. Median. That's the best measure of center. Great practice. What will this loop do right here? So what will that loop do? Does it say we need how many lines of code? Write the code, and then the 10 lines, yeah. So it's going to do this because that's not in the loop. So then what does this loop do right here? What does the loop do right here? It's the same thing as we were doing down here, but what does the loop do? So I might need to zoom out a little bit. What does the loop do on that line 86 first time? I'm not going to write the rest. I'm going to write part of this, and I want you to then figure out the rest. I'm going to kind of leave you on a cliffhanger on it. I'll be like, cliffhanger. What does it do on line 86? When the loop starts, like use our knowledge down there of how the loop works. Like what is the loop doing in the background? We're just trying to understand theoretically what this loop is doing. Nchar tells us the number of characters in Word. So, and that's the skeleton that never changes. So nchar tells you, like, if you go here and type, don't worry, this is just seeing what nCharacter does. This will say 4. It just tells you how many characters are in a word. If you say word, it'll say 4 characters. Or New York, it'll say there's 7 characters in New York. So nchar tells you the number of characters. So what does the loop do right here? Stores the well, go to what we were doing down here. When the loop initializes right here, what is it going to do? When the loop initializes right here, use your knowledge on what we just did. When the loop initializes on this, what will it do to the placeholder in the vector? So what will it do to the placeholder in the vector? And how would that look up here if we were to use the same sort of theory? Because the theory is what's important. So what will that loop do right here theoretically? Like we have to know what the code's doing in the background. We don't just code things. We're like, well, what does it do? Close, Kayla, you're super close. It's going to do that eventually. That is correct. And John sees it right there. John, that is correct. It's going to just store the first element into Word. So Word would become the first element right here. Does that make sense? Like it's going to store into Word the first element of the vector. Does that make sense? Like down here, Brian became the first element of the vector. This right here could be written as a vector like that. Does that make sense? Like this is a vector. It's still just 1 through 5. So Brian becomes 1, the loop runs. Brian becomes 2, the loop runs. Brian becomes 3, the loop runs. Brian becomes 4, the loop runs. Brian becomes 5, the loop runs. And the loop ends because there's no more things in the vector for it to go through. So then what would we run next? So don't just say, well, then you just run the what? What would run next right here after we change what the placeholder is? So we change the placeholder to the first element, and now we just run the what, which it never changes. It's just the same thing each time. Every time you do it, it's the same thing. It's the exact same thing every time. I think you see it, right, Kayla? The skeleton. And from here, if you see the pattern, you should know the full answer to the 10 lines of code. I'll probably leave this question right here on this because I'm going to try to do the 475 here coming up. But does anyone think, yeah, Jessica, if you're like, okay, I'm getting it, okay, because that's truthfully, Kayla, does it help to take sneak peeks into other classes? If you are interested in these types of things and kind of see what's going on here a little bit, to maybe see like some RMSE, some root mean squared error, some typical miss the model makes, and maybe you're like, get to that topic, you're like, I remember hearing that. You have to hear things multiple times, and it can really help. It can really help. I've had students already who are getting sneak peeks. Well, I'm so glad. And there was a theory a while ago that I should divide up office hours to different classes. One, I always like that we have lots of questions. Today we did so well on taking questions that we're just going to try to do as many. Oh, that's so awesome, Kayla. Thank you so much. And Jessica, if you ever have questions, let me know. And if you ever want to know more about these topics, oops, what'd I do? I'm vanished. I went away. I'm glad this is like a TV show. That's kind of my goal, is so we can just have some fun on these wacky Wednesdays. Crash, you know what's up. Let's get the assignment going right here. BAS 475. We got some assignment 2 stuff. We might not be able to get to Rain No Rain. We have done so much work today. Absolutely amazing. So yeah, I love it. Just come in, just chill, join in, ask questions, crack jokes, have fun. That's what we're here to do. We want to enjoy our time. Office hours are probably some of the most fun, especially when people are just here, because we just get work done as people ask, and it's a lot of fun. And the only way to get good at stuff is just to practice. It's the only way. So I'm really lucky. I get to practice a lot of stuff and it helps me with my skills. I'm also trying to get better at my skills all the time. We have a bot. The most fun office hours, usually office hours are... Oh, where'd it go? Where'd it go? Oh, thank you, Jessica, right there. Yeah, this is just chill. Oh, I miss... You should... When we had my office, we're getting further away from people remembering Brian's office hours. We would sometimes have like 20 to 30 students up in my office working. And so I need to get back to the days where we have a physical office and we just have students there, and maybe I could do online at the same time. We're actually having a meeting on Friday about VR. We might be doing some virtual reality. It's going to be pretty interesting. More on that later. Let me take the timestamp here for 475. Let's do some C&D. 121.12. Here we go. BS 475, part C and D. Okay, let's go here. You can actually click down to the beginning. Beginning regression. What? Oh, we want to go here. Chunk 5. There we go. Analyze the variance inflation between your X variables. Interpret this value to the reader in a way that they would understand the topic. So, Kayla, this is actually a topic towards the right after the midterm in 320. Variance inflation, which, you know what? Variance is something we talk about in 201. Variance is just standard deviation squared. Standard deviation is a measure of spread of your variable. Now, would you want your data to be very spread out or very centralized? If you want to have a good understanding of your data, would you want your variables to be very spread out? Oh, Zachary, that's awesome. Would you want your data to be very spread out if you want to understand it really well, or very centralized? Variance inflation, exactly right there. We want it to be centralized. So we want very little variance inflation. Variance inflation is a very, very bad thing. Variance inflation is basically inflating your uncertainty. Whoops, go away. Variance inflation is basically inflating your uncertainty. So what we need right here is we need a model. So to make a model, and this is what we were talking about at the end of class yesterday, centralized, great job, Miles, right there. We're going to make a model with the following. Well, first, let's load library reg class. Then let's load a data set. Oh, there we go. Don't worry, those are not errors. It's just telling me it loaded a bunch of stuff. I'm loading in some data right now, survey 10. I'm going to make a model saved into object M where I predict the height of individuals based on their weight, plus their GPA, plus their desired weight. And we'll go data equals survey 10. There we go. 3 letters, autocomplete. So this says make a model where the Y variable, this is just the Y variable, is somebody's height. The first X variable is their height, then their GPA, then those variables. So these are the X variables. Does that make sense? I have 3 things explaining the height of an individual. Is everyone following right here what this code says? It says, we want to understand why is someone a certain height? Well, let's use the X variable weight, which might explain it. Let's use their GPA, which might explain it. Let's use their desired weight. Now, what variance inflation is, conceptually, is when the X variables kind of step on each other's toes. Which of these 2 X variables are most likely? And remember, the X's are these. The X's explain. So your X's will have variance inflation. Which of these 2 X variables might step on each other's toes the most? As in, they're both doing the same sort of thing. We go into deeper details in 320 talking about variance inflation. But variance inflation is when your X's share the variation in what they explain. Like, they do the same thing. Exactly, Coral. Weight and desired weight are kind of the same variable. Like, knowing somebody's weight would probably tell you a lot about their desired weight. If you're like, I weigh 120, well, maybe you want to weigh around that, I guess. It doesn't mean you do. It's just that those variables are kind of similar. And the fact that they're similar, our model's going to get confused. If you have a friend who will bring you Krispy Kreme donuts or Dunkin' Donuts, you might be like, I don't know which friend to invite to my party. We'll go into more detail. But let's say, oh, do we have it still? What is that donut? What is the best donuts in Knoxville currently? Like, if you had a friend who said Krispy Kreme donuts, you're like, oh, those are okay. Or there was a really good donut place in Knoxville for a while. Like, they were such fancy donuts. They made like the breakfast donuts where it had like such good stuff on it. Can't think of it right now, but shouts to that place. I can't remember it. If someone says it, I'll be like, oh, it's an interesting name, but they were so good. And then they like sold it or shut down. I don't know. They're gone. Little Debbie's is the best. Duck Donuts is pretty good. So think about that. Those are more different. So if your friend who says Krispy Kreme Duck Donuts, you're like, Duck Donuts, you're at our party. So these variables right here, the unique friend is kind of Duck Donuts is some good stuff. Shouts to Duck Donuts. Good donuts right there. GPA is kind of the unique one. It does something different. So to look at the variance inflation is the variance inflation. And I didn't even show this one yesterday, Kayla, when I was talking about the easy functions to run. Variance inflation is just variance inflation of your model. That's the code to run it. So there's the variance inflation. The smallest possible variance inflation is 1. Variance inflation is the equation, and I'm not going to go into too much detail on this, I'll just mention it. But you'll see a concept we mention in all of our classes. The equation for variance inflation is 1 over 1 minus r squared sub I. Don't worry about the sub I right now. It's the r squared of the ith x in the model explained by the other x's. But that's an r squared. What is the smallest value of r squareds possible? So what is the smallest value of r squareds? We might just barely have enough time, John. We might go back. Or John, message me on Discord, John, and we'll talk through it. So John, I don't want to show the full answer 100%. Message me on Discord and we'll take a look. Or Miles, message me on Discord and we can talk through it. So that way we don't show the full answer. So kind of message me on Discord. Core's right, 0. So if you plug in a 0 right here, if this is variance inflation, what is the smallest value of variance inflation where your x's have no shared variation? If your x's have no shared variation, which what this is, no, you can start at any time and just come back to it. Great question right there, Zach. It won't mess anything up. It'll show a grade, but you can always improve it. Like if you start it, it's not gonna mess anything up. So this right here, exactly core, is 1. There is no variance inflation. That means like we've inflated it 0. Now, what does this approach? Be very careful, and I'll write it this way. What can variance inflation approach as r goes towards 1? What would variance inflation approach as your x's share all the variation? What would variance inflation approach as your x's completely overlap? Your variance inflation would approach what? Which is more uncertainty. Variance inflation is a measure of uncertainty on our x's coefficients. So that bottom part will approach 0. And 1 over 0, as it goes towards 1 over 0, that actually approaches, it goes to an undefined, I believe, but that will approach what? So I didn't put the 1 there, but this will approach as you go towards 0. 1 over a very small number will approach infinity. So you know what's really interesting? You actually want, and there's a lot more details, this is not your regular old r squared. You want your r squared sub I to be very what? You would like your r squared sub I to be very what? R squared sub I is the shared variation with the ith x in the model with the other x's. It's how do your x's explain the ith x. So r squared sub I is the r squared of the ith x in the model, like any sort of x. We have 3 of them. We have our 3 variables, and it's how much is this variable explained by the other 2 variables. So you want your r squared sub I actually, so core reverse it. This is a weird thing because you don't want your x's to explain each other, because this is how are your x's explained by your x's. You want your x's to be explained. You want your x's to explain your y. Megan, I think we got just enough time. Great question, Megan. So you want your x's to explain your y. So you do not want high r squared sub I. If you have a low r squared sub I, you will get a low variance inflation. So the variance inflation over here, the one that is really good is this. This means GPA, and maybe remember this from 320, GPA brings with it unique information not accounted for by the other variables. It looks like desired weight and weight have some overlap with what they're bringing to the model, that they are explained by other variables, meaning that we have more uncertainty in their coefficients as shown by the variance inflation. Does that make sense, Core, right there? Due to the higher variance inflation for desired weight and weight, it looks like they have shared variation between the other x's in the model, which means they are not bringing with them a lot of unique information. There's kind of an overlap to what they bring to the model. GPA brings with it the most unique information as shown by the variance inflation, where it doesn't have much overlap between the other x's in the model, leading to very low levels of inflated uncertainty. What if hypothetically I get a VIF for my 2 x variables? So if you have 2 x's, it'll actually be the same because we have basically how does this x explain this x and how does this x explain this x, And so this right here is very low variance inflation. So there really isn't a lot of overlap between these two x's right here and what they bring to the model. The variance inflations are close to 1, showing that we don't have increased uncertainty due to our x's kind of landing on top of each other. Miles, 100 points, perfect answer. I didn't even say multicollinearity. Miles just getting 100 points right there. Variance inflation is a measure of multicollinearity. Interestingly enough, to be specific, this one is multicollinearity, and this is technically collinearity. Multicollinearity would be the shared variation between GPA and weight and the other ones, but since there's only 2 x's right here, it would be a collinearity issue. You can go into linear algebra with this kind of stuff too, but the multicollinearity is in the model with the 3 x's, because multicollinearity would be the shared variation with an x and multiple x's. Collinearity would be the shared variation with 1 x and another x in the model. So Miles, great answer right there, and you could just call it multicollinearity, like just like a lesser multicollinearity. But yeah, that's the concept of multicollinearity. Excellent answer, Miles, right there. Talking about it that way too is excellent. Makes prediction intervals. I think we did this one yesterday too. Here, we're going to do it real quick. We're going to try to do this one in 3 minutes. Sorry if this is a little quick, and thank you to everyone if we didn't get to questions. I think, Miles, you might have asked one too someone asked an additional one that we didn't get to. Let's put an R chunk right here and go to Q5D. I'm going to do this one a little bit quickly and kind of just go to some answers on it. So we've got make prediction intervals for an individual in the model. You'll call just the one individual's prediction interval and interpret what this means. Okay. Predict our model. Now, here's the thing. This will just make predictions using everything in our model. So we were seeing this yesterday, Kayla, where we can use these small little functions. This says make predictions for everyone in the model. I have now just predicted everyone's what's. Just a few quick answers in the chat. Let me send out the announcement to 201. We have just predicted everybody's what right there. I have just predicted, while I'm sending out the announcement, help me out. I have just predicted every single person's what. I didn't call that last class by its name. Oh, let me change one thing. We have just predicted everybody's what? 2 seconds while I edit a title. Chapter 3, bivariate categorical data. Save that. I'm missing out the playlist, the link. We have just predicted. I'm assuming people said height. Thank you. 100 points, Miles and Cora right there. We just predicted everyone's height. So now, how could I go to just one individual in this prediction set? Help me go to just one person. So, how do I go to just one person? Like the first person, the 10th person, go to a position, just go to that person. How would I go to just one person? A lot of exclamations in my announcements. How do I go to just one person, like the 15th, the 10th, any sort of person right there? How do I go to just one person? How do I go to just one person? Doing the setup right here. That's how I do my timer. 2 seconds. Start. How do I go to just one person? Exactly, Cora. Great work. But here's the problem. We don't have... And so that would go to the 10th position in the model, and that gets mad. This goes to the 10th prediction in the prediction vector. Does that make sense? This is the 10th prediction in the prediction vector. But we don't have prediction intervals right now. So we should probably add an additional what to our prediction function. So we should probably add an additional what to our prediction function, because we need to give it more instructions. And this, if you're in 320 or anything, you're like, oh, wait a minute, because 320, we talk like this a lot. We say like, oh, we should probably add an additional what to our prediction function. We need additional instructions for it. We need to talk it through. And we need to do what? We need to give it more instructions, so let's give it another what? Let's give it another this. So we need to give it more instructions. Let's put an additional what inside of it. Kind of a condition. So you might be thinking, great work with there, Cora. I think you know what you're saying. I bet you would think I should put a what right here. Just put one little character in the chat. I should probably do a what right now. And not necessarily conditions. Miles, exactly. Argument right there. Both you points. So put another argument in and say interval equals prediction. Oh, what's it mad about? Did I misspell it? Predictions on current data refer to future. What? Oh, wait, did we get it? Did I make a mistake? Let me look. Am I losing my mind? You never know. Predictions on current data refer to future responses. Man, I thought we could get all my predictions. There's prediction intervals. That's prediction intervals right there. Okay. You want to be that way? Data frame. Data frame on my prediction intervals. And then let's go right here and go to position 10 in the data frame. There we go. I was like, it should work. What was it doing previously? Was it showing the answer? I think it was giving a warning maybe. So here's the code. And let me copy it. Yeah, it's giving it. No, it's not. Why would it not? That's interesting. I didn't know it did that. So store the data frame. And this is a person in the model. This is person 10. Store the data frame, and there's person 10 right there. I don't know why it doesn't give the prediction interval for the individual. Kind of a wacky interval. I would be 95% confident. We could change the, I think it's level is the function to do it here. Or the argument, excuse me. Level equals 99. I am 99% confident. That isn't, yeah, okay, it did it. I am 99% confident that this individual would have a height contained in the interval 4'9" to 6'3". It's a pretty big interval. I am 99% confident that this individual would have a height. You're welcome, Cora. I am 99% confident that this individual would have a height contained in the interval 4'9" to 6'3". Literally, like the shortest friends I've ever had to my height. That's a pretty big interval. It's a lot of uncertainty. We should visualize this model. And yeah, it's kind of crazy. It's not the best of models. We have a multivariate model. We're using GPA and stuff like that. So we're getting multivariate output. GPA is not a significant coefficient as seen by that right there. GPA is not significant. And that would tell us right there GPA is not significant or unlikely to be from the differences between the, what are these called? The implicit lines. Couldn't think of the word right there. So yeah, lots of stuff going on, and the code gets a little bit easier, but the terminology remains the same. So if you were 320 checking this out, make sure to understand terms like arguments. We're just trying to save into an object like a data frame, and then going right here. I don't know if you have time, but can you send a question on 3A? Let's look at 3A real quick. We got just enough time. I'll grab a quick yogurt between class. Let's do 3A real quick right here. That was asked earlier, so I do want to try to do that. And we got through a lot of stuff. We didn't get to Kayla's question. Kayla, thank you so much. I can probably talk on Discord on it. So let's do question 3A really quick right here, and then I'll jump over to the stream. Run a t-test to see if students have an average GPA greater than 3. Interpret the results below. For someone who is not a statistics source, interpret the values. So when we want to run a t-test, we want to go right here, and a really good thing to do is always go $t.test. Now remove these when you knit these, but this walks you through kind of what's going on right here and how to use it. So always do like the question mark. If you're going to knit though, make sure to comment those out. If I learn how to comment again, I thought I was doing a block comment. Did I just copy it? Did I? There we go. Comment those out after doing it, but do take a look. There's a lot of options, whether you're doing paired, an equal variance test, your confidence levels, all the different things like confidence levels was level before. When I was running the code down here, I used a function to get a certain confidence level. So the t.test is a t-test, and we're doing the one sample t-test. So the first thing you need to put into it is the data. So we need to go here to data and take a vector of data like height. Now, interestingly enough, you can actually run this, and you know what we do? We always code in little bits. So now we've actually just run a t-test, but we're not testing a specific value. It's currently testing 0. I guess that is a specific value, but we want to specify the value, and you can see what the value was set to by default. It's going to use a default that the true mean is equal to 0, but maybe we want to see if the true mean, mu, is equal to, let's say, 70 inches. And now we just change the value. Interpret the results is greater than, so now we need to pick a different argument right here. So we need to set the alternative argument. We'll make it look all nice and pretty right here. Another argument, alternative equals, and we can see which one we're going to pick. The greater than, Zach, great to see you here. And there's actually 0, don't worry, but no, still love that people are just hanging out here. And now we can do this test. So let me interpret these results right here, but we've kind of done the structure of what needs to be done. When you're looking at this right here, the t-test lets us analyze the mean, which is a quantitative value, to see if it is less than, greater than, or not equal to a certain value. And kind of just read through a little bit on these if you want some more details. But one of the biggest things that this assignment tries to do is reviewing and also helping us understand how to kind of look through stuff. So great work, like traveling right here. And this is in 201 and in 320. So we have here a t-test, very end of 201 right here. What we have right here is a t-test showing us, awesome, Zachary, see you then in a moment, 8 minutes. We have right here a t-test showing us that we tested to see if students' heights are greater than 70 inches tall. Oh, you're fine. I don't care. And we actually failed to reject the null hypothesis. And you might say, well, students' heights are much lower than that. Well, you're right. Then we would not have evidence that their heights are greater than 70 inches tall. The p-value here was very high at 1, meaning we failed to reject the null hypothesis. Now, I could have done, I think it's less. This is less. There's the less than. And now we would actually reject the null. That's a very low p-value. That's not a p-value of 2. P-values only go between 0 and 1. So in this instance, if I were to test the less than alternative, I would have evidence that people's heights are less than 70 inches at UT. I have evidence that the true mean height of UT students is less than 70 inches tall because the p-value is less than 0.05, which is strong evidence to indicate we should not, almost said a very bad word. Strong evidence to lend credibility towards the alternative being true. Not that we should A-word it, accept it. Don't say that bad A-word. Cora, did this help out right here? A little bit quick on this. Oh, thank you, Mason. Thank you so much. A little bit quick because we're about to start class in 7 minutes or 6 minutes. Timer's already up and going. We have 6 minutes and 45 seconds to class. I'm going to end the stream right here, and I'm going to start up the 201 stream. I will see 201 here in just a little bit. You're welcome, Cora. Drop those questions on the Discord. Drop in the chat. We're going to say bye. Puppet Shark, say bye to everybody. That's not bye, Puppet Shark. Bye. You too, Jessica. Bye, everyone. Coffee's gone. You're welcome, Miles. Have a great day.